everyone, welcome to Mina's Tech YouTube channel. So today we will be discussing about 12 factor methodologies of microservices. So what exactly are these and why we need these? So before creating any microservices, you must follow this 12 factor methodology of microservices. Yes, you can Google it saying 12 factor methodologies in microservices, and there are a lot of information in it. So let's make it very simple and try to understand what are these 12 factor methodologies. So let's get started. So let's dig into 12 factor methodology for microservices. The 12 factor methodology provides a set of best practicing for building modern web application, ensuring they are scalable, maintainable, and portable across different environments. These principles are highly relevant in the context of microservice. Here is the breakdown for each factor and its application in Java microservices. They are code base, dependencies, config, packing service, build, release and run, processing, port binding, concurrency, disposability, dev production and parties, logs, and admin processing. So let's see each and every factor which is required to build microservice application. Code base. One code base which can be tracked in version control and can be done multiple deployments. In a microservice architecture, each microservice should have its own code repository. Use version control system like Git to maintain the version controls. Dependencies. Manage your dependencies explicitly to ensure consistent environment across development, testing, and production. We can use Maven or Gradle to maintain and manage our dependencies. For Maven, we have pom.xml where we maintain all our dependencies at one go. Config. Store configuration in the environments. Store configuration settings in environment variable, not in the code. So use application.property file or application.yaml file for Spring Boot application. So inject environment variables like server.port, server.datasource. Backing services. Treat backing service as attached resource. Treat databases, messaging systems, and other services as resources attached to your application. Configure these services via environment variables. Build, release, and run. Strictly separate build and run stages. Separate the stage of building, releasing, and running the application. Build. You can compile the code and package like Maven package. Release. You can release and combine the build with configuration settings. And run. You can execute the application in targeted environments. Processes. Execute the application as one or more stateless process. Application should run as stateless process with state stored in the backing services. Each microservice instance should have stateless and shared nothing. Use databases, caches, or object storage to persist state. Port binding. Export services via port binding. Each service should expose its functionality over the port binding or port. So we have server.port equal to 8080, which is default one for microservices. Concurrency. Scale out via the process model. Scale the application by running multiple instances for each service. Use process manager or container to manage scaling. Disposability. Maximize robustness with fast startup and graceful shutdown. So service should start quickly and shut down gracefully. Handle termination signal for graceful shutdown. For example, on shutdown method, which is @predestroy. Dev prod parties. Keep deployment, staging, and production as simple as possible. Minimize differences between environments to avoid issue. Use Docker to create consistency environments. Logs. Treat logs as event streaming. Aggregate logs from all services and treat them as event stream. Use centralized logging system like ELK Stack or Splunk. Admin processes. Run admin management task as one of processes. Run administrative tasks like database migration as one of processes. Use tool like Flyway or Liquibase for database migration. So these are the 12 methodology provides to create a robust microservice. Applying these principles in Java, especially with Spring, helps ensure that your microservices are scalable, maintainable, and portable across different environments. Each factor addresses a key aspect of modern application development, from managing dependencies and configuration to handle logs and scaling processes.